everyone. In this video, we are going to discuss your second program, which is on process control system calls such as fork, exec, wait, etc. And then we are going to discuss the concept of command line arguments. We are going to apply these concepts to build an application which demonstrates the execution of a parent and a child process. So let's begin. In this slide, we are going to discuss the various system calls. So first is getpid, getppid. Whenever a process is created in the system, the operating system assigns each process a unique number that's called as a process ID of the process. And the getpid function will return the process ID of the calling process. And getppid will return its parent process ID. Wait system call is always used by the parent for its child to complete its execution. It basically blocks the parent until one of its child process exit. The wait function will return the PID of the terminated child, and this argument status will return the status of the terminated child. Next, execl system call is used to execute a binary file. And the first argument to exec is the path of the binary file. The second argument is the name of the binary file itself. And the third and all the consecutive arguments are going to be the arguments to your binary file. The last argument should be null, indicating the end of the argument list. The execl function never returns upon success, whereas it returns -1 on failure. The next system call is exit. Exit terminates the calling process. And the parameter that you're passing to exit will be the termination status, which will return to its parent. Next is fork system call. Fork is used to create a new process by duplicating the calling process. So a process, when it calls a fork, it creates a new process. We call it as child process. And this child is exactly duplicate of the parent process, meaning it is going to have the same program as that of the parent. Now, once after the fork is called, now there will be two processes executing same set of instructions. The difference between the parent and the child after the calling fork is that in the parent, the return value of fork is going to be the child process ID. And in the child, the return value of fork is going to be 0. Right? So then we in the system after fork, we have two processes executing with the different return values. So we are going to use this and differentiate the task that the parent is supposed to execute and the task that the child is supposed to execute. So here you can see after the fork is called, the return value P is stored in PID. For the child, the PID value is going to be 0. Thus, we are going to use this if-else structure to differentiate the tasks. So if PID is equal to 0, this block of code, we are going to put the instructions that the child should execute. And in the else part, we are going to put the set of instructions that the parent is supposed to execute. So in this way, we can separate the execution of a parent and a child. Next, let's discuss the concept of command line arguments. Command line arguments are the values that you pass to the program from the command line or the bash prompt. For example, here you can see for the a.out, I'm passing a command line argument hi. So this value is passed into your program with the help of arguments to the main function. So the main function, it takes a fixed set of arguments. First one is an integer argument argc, and the second one is an array of pointers. So the argc, it gives you the value of the count of number of arguments that you're passing to the program. So in this case, hi is passed to a.out. So the argument count is going to be 2. That's because it's going to count the executable file also as an argument. Whereas argv of 0 will be a.out and argv of 1 will be hi. That is, the argv stores the arguments themselves. So I hope you understood the concept of command line arguments. Now let's proceed to execute the program. So in order to execute the program, first thing is we will create a binary file which we want our execl to execute. So here is an example program, and in this program I'm taking the command line arguments, as you can see here, and in the first line, that is the line number 8, I'm converting the argument 1 to a integer value. As it's a character pointer or a string, we are going to convert it to integer using a to I argument, ASCII to integer. And then I'm initializing some variable to 0. And you can see here, using the for loop, I'm finding the sum of n natural numbers, where n is passed as an argument to this program, right? And then I'm printing the sum here. Let me execute this code. Now you can see a dot out, I'm passing the argument as 5 to this. So you can see it has calculated the sum of first five natural numbers and printing the output as 15. Now our application is ready, but we want the application not to have name a dot out, but to have some meaningful name. So I'm going to compile this program again with a meaningful name. So I'm going to use switch dash o with cc to give the name. Let me give the name as app itself. Now app.c. So what I've done here is I'm renaming the output file from a.out to app. Right? Now to execute this, I'm going to execute it as app and file. So you can see it's the same. Next let's go to the main program. So in this program, we are going to use call for create a child process, and the child process is supposed to execute the binary app. So here I have included various header files. This is a program in which we are going to use fork and exec, right? And the child is going to execute the app application that we have already created in the previous step. We have created a binary file app in the previous step, right? So we are going to use the child to execute that binary. Now, as usual, in the main, we are taking the command line, receiving the command line arguments. Here I am declaring int and wt as integer variables. I'm calling fork. The return value of fork is captured in id. Right. So at this point, what happens? Child process is created, and the child process is going to execute the same copy of the program. And any process may schedule first. The child may execute first, or the parent may execute first. Let's assume that the parent is scheduled to execute first. So now the parent is executing. Okay. So the ID value in the parent is going to be the child process ID, which is greater than 0. So the parent is executing. See, this line number 12 will be false for the parent. So it will come to the else part, where else if ID is greater than 0. So this is going to be true for the parent. So it's coming in the if block. Parent is entering into the if block. At line number 20, it's calling wait system call. So this wait system call is now going to block the parent until the child completes the execution. So now at line number 20, the parent is blocked. As the parent is blocked, the child will be scheduled for execution by the CPU. Okay, now let's say how the child executes. So in the child, the ID value is going to be 0. The child is continuing the execution. So this line number 12, ID equal to 0 is going to be true for the child. So then the child enters the if block. It prints, hi, I'm child. My PID is getPID. Right? It's going to print the child process ID here. And then the second printf child. My parent ID is PID, getppid. So it's going to print its parent ID. Now the child is calling execl, and it's going to execute the app. Right? And this app, we are going to pass value 5. Let me pass value. Let me pass argv of 1. Let me pass argv of 1. Okay. So whatever argument I'm going to receive from this program, that argument I'm going to pass. Okay. I forgot here. So the first argument is path, which is in the current directory. This binary file is stored. The second is the name of the file itself, app, and the third is the argument. The argument is the first argument that we are going to pass to this program, the same argument we are passing to the executable file. And then the child is exiting with the exit status of 34, right? So with exit, the child process terminates. Now the moment the child process terminates, the parent, which is blocked on wait, will resume the execution. Okay, so the child has terminated now and the parent will resume execution at wait. So it will correct the termination status of the child in WT. Next, the parent prints the first printf statement. Hi, I'm parent and my PID is %d. So this PID and this PPID in the child should match. Then the parent prints parent, my parent PID is %d, get PPID. So this line number 22 is going to print the bash PID because we are executing the program on the bash prompt, right? So the bash is going to be the parent for this program. So this is going to print the bash PID. So after this two printf statement, now we are going to use the argument from the wait to determine the termination status of the child. Now, so if exited macro will return true in case the child has terminated normally. So you can see it's taking the WT as an argument and then it returns true if the child has terminated normally. So in this case, we are printing the child is terminated normally and its exit status is %d, W exit status WT. This is going to print the exit status of the child, right? And then if this is false, the child has not executed normally, then it's going to print we are going to check W if signaled. So this is going to be true if the child has terminated abnormally. So in this case, we'll print a message, child has terminated abnormally and is killed by signal %d. So this wtermsig macro returns the signal number using which the child was terminated. So in this way, we are determining whether child was terminated normally or abnormally using various macros. W if exited, if the child will return true if the child has terminated normally, whereas W if signal will return true if the child has terminated abnormally. And further, using W if status to display the child termination status and wtermsig to display the signal using which the child process was terminated. So this is the program. So I hope you understood this. So go ahead and create any application. This application can be a program to encrypt a file. It can be your sorting program. It can be your searching program or some string program. Various other applications. It can be any application. Now, once you write this program, create an executable file just like I did, just like we did, right? So you create, compile the application program and create an executable file. And once that is created, you're going to use that executable in the child to execute using execl. So I hope you understood this particular program. So go ahead and execute this. Thank you. Thank you, one and all.